Okay, in this video we continue with the definite integral. We're going to work through these examples here. There is 10 of them. Now you're going to notice that these examples are going to be a bit more challenging than the examples we started with in part 1. In particular, for these examples, we are going to need to use the methods listed here: use substitution, partial fractions, trigonometric substitution, integration by parts, and integration of trigonometric integrals. So this video is also going to give you or at least give you an idea on how to choose which method to use whenever faced with an integral. Of course, we have done a series of videos on each of these methods. We shall put the link accordingly as we come across each one of them. All right, so let's go to part A. So in part A, we've got the integral of 9x times square root of 1 plus x squared dx from 0 to square root 8. So for this one, if you look at this function 1 plus x squared and this function here, we notice that if you differentiate this, you get something which is a constant multiple of that. So that's a hallmark feature of integrals that can be evaluated using use substitution. Just going to put the link for our videos on use substitution right now, which you can check so that you can get a better understanding of what we are talking about. So what we're going to do here is if we make this integral to be we're just going to call it I, then we're going to let u be equal to 1 plus x squared. Then du is going to be 2x dx. But in the integral here, we've got 9x dx. So from this here, if we divide by 2 and then multiply by 9, so we're going to have 9 over 2 du this side, and then this is going to be 9x dx. So that means we can write the terms underlined in blue here entirely in terms of u. Now, something that's going to be an addition to what we did when we did the u substitution is the fact that we have got limits now. So when we've got limits, we also need to transform them from the x variable and write them in terms of u. Okay, so for the limits, we're going to say when x is equal to 0, that's this one, u is going to be equal to, so if you plug in x equal to 0 here, you're going to see that u is going to be equal to 1. And then when x is equal to square root 8, which is the upper limit, then u is going to be 8 plus 1. So u is going to be 9. This situation, we usually write it like this. The shorthand of it goes like that. So we say as x changes from 0 to square root 8, u changes from 1 to 9. So that's the notation we're going to use henceforth. So what's going to happen now is the integral we can write as the integral from 1 to 9. Okay. Then this bit here is just square root u, so that's going to be square root u, and then 9x dx is 9 over 2 du from here. So this is just an integration of u now. So I've got 9/2 into the integral of u to the power half. And so if we add 1 and divide, we're going to get 3/2. So that's going to be integral. It's going to be u to the power 3/2 divided by 3/2, which is the same as multiplying by 2/3. So this is going to be 3u to the power 3/2, and then evaluated between 1 and 9. So this is going to be 3 times 9 to the power 3/2 minus 3 times 1 to the power 3/2. 9 to the power 3/2 is 27, and 1 to the power 3/2 is 1. So this is going to work out to 78. So that's going to be the value of the integral in part A. Okay, so moving on now to part B. So in part B, we have got the integral from -2 to 2 of the square root of 4 minus x squared dx. Okay, so just looking at this integral here, there is no other term which looks like the derivative of this. So that means we can not use u substitution. This is not a polynomial because of the square root, so we can not use partial fractions. However, it's got a quadratic term here, so that makes us think we could use trigonometric substitutions. And indeed, that is what we are going to do. Because the x squared is negative, then that tells us that the trigonometric substitution that is relevant here is the sign. Again, we're going to just put a link for our videos, which are going to give you more background on how to use the method of trigonometric substitution. But basically it works if you have got a quadratic term that has that could be of this form, yeah, and there are 2 other forms which are going to be given in those videos. So in this case, we're going to let x be equal to 2 times sine theta. So dx is going to be 2 times cosine theta d theta. So these 2 are now sorted. The next thing we need to sort out are the limits. So again, so when x is equal to -2, so when x is equals to -2, I'm just going to put the theta thing here, and then we are going to work them out this side here. So when x is equals to -2, I'm going to plug in -2 there. So we're going to have -2 equals to 2 times sine theta. So this thing is giving us sine theta is equal to -1. And then the smallest value of theta closest to the origin, for which sine theta is -1, is going to be -pi/2 if we solve this trigonometric equation. So that means we are going to have -pi/2 here. And then when x is 2, that means we're going to have 2 there. So this time our equation is going to be sine theta is equal to 1. And then again, the smallest value for theta, for which sine theta is 1, is pi/2. So that's going to be our new limits. So our integral is now going to be from minus pi over 2 to pi over 2 square root of 4 minus 4 sine squared theta, then dx is 2 cosine theta d theta. The 2 we can factor out, then inside the square root here is 4 into 1 minus sine squared theta. So 1 minus sine squared theta we know is cosine squared theta. So this is going to be square root 4 times cosine squared theta. Sorry, the 2 we already factorized. So this is just cosine theta. And then, sorry, the limits. Square root of 4 is 2, and square root of cosine squared is cosine. So this thing is now giving us 4 into the integral from minus power 2 to power 2 cosine squared theta d theta. This we can integrate, and the rules we deliberated on in our videos on integrating powers of sine and cosine. I'm going to just give you the link now. When the power of sine or cosine or both of them is even, we use the double angle formulas. So in this case, for the cosine squared, double angle formula is 1/2 into 1 plus cosine 2 theta. Then integrating this gives us theta plus 1/2 sine 2 theta. Just notice that whenever we are working with trigonometric functions in calculus, the angle is always in radians. So this is going to be 2 times pi on 2 plus 1/2 sine 2 theta will be pi, then minus 2 times, so this time is going to be minus pi plus 1/2 negative pi sine negative pi. Now sine pi and sine negative pi are both 0, so the only contribution here are going to be these terms, and this is going to work out to 2 pi. All right, so that is the first 2 examples. Okay, so we're going to stop this video here and continue with the other examples in the next video, which is going to be our part 3. Thank you for watching. Hopefully these are useful. Please do not forget to press the subscribe button so you in the next video. See you there.